The section's on 4.3, connecting first derivative of f and second derivative with the graph of f. This is going to be part 1. So part 1 is now actually creating charts and filling in the charts and getting a summary table at the end. So that's going to be our goal. So the example that we have is something like this, where it says f of x is equal x to the fourth right there minus the 4x cubed. And the first step is then to take that equation and we're going to set it equal to 0 after the first derivative. So let's take the first derivative of that. So first derivative is equal to 4x to the third minus 12x squared. So once we take the first derivative, we're going to set it equal to 0. So 0 is equal to 4x to the third minus 12x squared, and we're going to solve for x. So if I factor out a 4x squared, so 4x squared, I'm going to have as x minus 3. So one of the solutions for x is going to be x is equal to 0 on that one, and x is equal to positive 3. Now I also like to put these on the number line right here, so that way it'll help me for the next part, which is the graphing or the table part of it. So at x equals 0 right there, and x equals 3, put 3 right there. Now I have to come up with the intervals when we get to step number 2. So the intervals right here are going to be from 0, the negative infinity to 0 basically, and then from 0 to 3, and then from 3 to positive infinity. Okay, so those are going to be my intervals. So I'm going to just go call it x is less than 0, right? And then x is between 0 to 3, so between 0 to 3, and x is greater than 3. Okay, so for the first part where it says find the sign of f, you're going to actually take a random number that is less than 0 right there, and we're going to substitute it into the first derivative because we did the first derivative right there. Okay, so we're going to substitute some number in. So let's say like -1 because it's less than 0. So if I substitute -1, now there's a couple places to substitute it in as well. We can substitute it back into this part right here where we found the first derivative, or you can actually substitute in here because this is already now simplified part of it. So let's put it in here because it's easier if we put it in there. So if I put in 4 to the -1 squared, right, and then also -1 minus 3, and so we're trying to figure out what this is right there. So -1 squared is positive 1. Positive 1 times 4, right, is going to be 4. This is going to be -1 times minus 3, so that's -4. So that's going to be together is -4. So you're going to get a negative number. So all I need to know is it negative or positive? So that's going to be negative right there. Okay, now let's pick a number between 0 to 3 and something like positive 1, right? Because something's simple. So doing the same thing again, we're going to go ahead and substitute 1 into that simplified form right there. And we have 1 minus 3 right there. This is going to be positive right there. This is going to be a negative, so final product is going to be a negative right there. Okay, because it's positive times a negative will be a negative. Let's pick a number after 3, so like 4. So 4, if I have 4 squared, right? 4 minus 1, I'm sorry, 4 minus 3. So this right here is going to be positive because 4 squared is 16. 16 times 4 is going to be something positive. 4 minus 3 is 1, so that's positive. So positive times positive will give us positive right there. Okay? The next part is the behavior. So the behavior we're writing is increasing or decreasing depending on the sign. So since this is negative right here, this is then decreasing. So I'm just going to shorten it and put DEC for decreasing. And then I'll put is this right here is negative, it's decreasing. And then this right here is positive, so this is increasing. Okay, so that's step number 2. Now step number 3 then is to take the second derivative. So we took this right here, the first derivative, the 4th x to the third minus 12x squared. So let's rewrite that. So under my third step, I'm going to take it for 4x to the third minus 12x squared. And we're going to take the second derivative. So f double prime right there is equal to 12x squared minus 24x. And we're doing the same steps again. So now we're going to take that, we're going to set it equal to 0. We have is then 12x squared minus 24x. I'm going to factor out a 12x, right? So we can factor out a 12x. So then we have is x minus 2. So one of the x's will be at x equals 0 and x equals 2. So doing the same thing, we're going to put it onto the interval right there. So at x equals 0 and x equals 2 right there. So again, this is going to help me set up my intervals. From there, I know it has to be x is less than 0 right there, x is between 0 to 2, and then x is after 2, so it's greater than 2 right there. So when I put now the intervals together, what we're going to have then is when x is less than 0, x is between 0 to 2, and when x is greater than 2. Okay? So now doing the same thing, we're going to substitute in a number into now the second derivative right here, because we just did the second derivative. So again, probably put it into the simplified right there. That's probably the easiest place to put it in. So x is less than 0, which is like a -1. So if we do 12 times -1, and then I have is -1 minus 2. So this is negative right there, right? And this is going to be a negative, so this becomes a positive right there. Okay? Now do the same thing. Between 0 to 2 is +1, so 12 times +1, 1 minus 2. This is a positive number right there. This is a negative number, so final product will be a negative. And then we have the last one. Let's put in like a 3, so 12 times 3. And then we have a 3 minus 2. So this is positive. This is positive, so final product is going to be positive. Okay? Now, the difference on this one, though, when we do the behavior, it's going to be concavity, because second derivative is concavity. So we're going to put then concave, and since it's positive, I'm going to go up. This is concave up right there. And since this is negative, we're going to say it's concave down. And then the last part right there is going to be concave up. Okay? So that's your next step. Okay, now we're done with the different parts. We're done with the first derivative. We're done with the second derivative. And now we actually have to put it together and make a summary table. So let's then talk about is the summary table. Okay, so the summary table looks something like this. We're combining those two charts together, and we're only going to combine the intervals and also the behaviors. We're not going to combine is the sign of. Okay, so now this is where I also like to do this, where I put my number line together, because this is where it's going to come in handy. So we used 0 to 3 on this right here. So I'm on this number right here, line, I'm going to go ahead and put 0 to 3. And then we also used 0 to 2, so I'm going to also put 2 right here. I don't need to put 0 since it's already there. This is going to help me then put it into the intervals up here. Okay? So the intervals, again, when we have this, it's going to be then anything that is less than 0, between 0 to 2, from 2 to 3, and then from 3 on right there. So let's put that intervals together. So when x is less than 0, when x is between 0 to 2, right? So 0 to 2, oops, I got to put an x there. Okay? And then when x is between 2 to 3, so between 2 to 3, and when x is greater than 3, right? Okay, so then greater than 3. Okay, so that's going to help with the intervals right there. Now, from there, all we're going to do is now go back to the tables that we used for the behavior for f and also behavior for f prime, and use that to figure out the rest of this. So with this again, this is the behavior of f right there. So from here, we're going to do the decreasing, decreasing, and increasing. So when it's x is less than 0, we have that on this chart right here. When x is less than 0. So that's easy. So then we could just write as decreasing. So then I write down over here as decreasing. Okay? Now when x is between 0 to 2. So from here, here's the problem. We have 0 to 3. So obviously 0 to 2 would have to fall in here. So if it falls in here, it would have to be decreasing as well. So then we have on this side right here is decreasing. Now, between 2 to 3, when we go back to this chart again, 2 to 3 falls in here still, right? So then it's still decreasing on this part right here. So between 2 to 3, it's still decreasing when x is greater than 3. So when we look at this chart right here, greater than 3 is increasing. So I'm going to write down as increasing right here. Okay? Now do the same thing now for the behavior for the second derivative that we did. So when x is less than 0, we went to this now on the second chart right here. When x is less than 0, we said it's concave up. So on this part right here, we're putting concave up. Okay? When x is between 0 to 2. So from here, 0 to 2, right there falls in right here, is concave down. So we have then as concave down. Okay? Now when x is between 2 to 3, so when I look at this right here, between 2 to 3, anything basically after 2 is going to be concave up right there. So for this right here and this, because it's after 2, I'm just going to go ahead and put concave up and concave up, right? Okay? So then from there, we're going to go ahead and do the graphing, which is then part 2 of this video. Okay? So again, let me go back to what we just did. So the first part right here is then taking the original equation, take the first derivative, set it equal to 0, solve for your x's right there. Then from there on a number line, just put it the x's that you have. So that's going to help you with the intervals right here. So if it's less than 0 right there, between 0 to 3, right, those are your intervals right there. And then when x is greater than 3. So that's that. This right here is first derivative. So you're going to go ahead and substitute a number that you have in here into the first derivative. So pick a point in here. Substitute it as long as it's less than 0. Substitute it in here. Find out if it's positive or negative. Same thing with this one. If it's between 0 to 3, pick a number between 0 to 3 and then substitute in there. Do not pick 0 or 3 because then it's going to come out to 0 right there. Okay? And x is greater than 3, then go ahead again, substitute it back into here. It's probably the easiest place. If you want to put it up here, that's fine. It's nothing wrong with it. But I would suggest just putting it in here. Okay? Then from there, once it's minus, we say it's decreasing on the first derivative. So minus is decreasing on the first derivative, and then plus is increasing on the first derivative. Then we do the second derivative. So now we take the first derivative equation, we take the second derivative, we do the same thing. We factor out, solve for x. X is equal to 0 to 2. Put it on the number line right here. This is going to help us again to put the intervals together. So from the intervals, when x is then less than 0, right? X is between 0 to 2, so that's right here. And x is greater than 2, which is this right here. From there, again, pick a point that is less than 0 and substitute it back into the second derivative and look for its positive or negative signs. So same thing with this one. Put it back in here. Put it back in here. Probably this one is the best place because it's simplified. But in this case, when we do the behavior, it's concave up or concave down, depending on if it's positive or negative. So in second derivative, when it's positive, it's concave up. Second derivative, when it's negative, it's concave down. Second derivative, when it's positive, it's concave up. Okay? So then the final is then to put a summary table together. So to put a summary table together, we're going to use the tables from 1 and 2 and put it all together. So I would then suggest using the numbers that you have here and also here, create a summary table, a number line right there. And then from there, that's going to help us to find the intervals because when x is less than 0, x is between 0 to 2, and x is between 2 to 3, and x is greater than 3. So that's how we got those numbers up here. Okay, now using the behavior of this from 0, this is what we're looking at right there. We're saying it's decreasing. When x is between 0 to 2, if 0 to 2 falls in here, so it'd still be decreasing. From 2 to 3, it still falls in that decreasing part right there. And then when x is greater than 3, it's going to be in here. So that's going to be greater than 3 is increasing. So we have it increasing right there. Okay? And then the final part is the behavior. So again, same thing. When x is less than 0, so when we go to less than 0 down here, it's concave up. So then from there, we're using the concave up. When x is between 0 to 2, 0 to 2 right here is concave down. So we have concave down. Anything x is greater than 2 is all going to be concave up. So over here, because these are greater than 2 right there, that's going to be concave up on that. Okay? All right, now go ahead and try the classwork.